I'm what you call a planetary defender. You probably only heard of that term in a comic book or in a science fiction story, but the reality is they are out there. There's not many of us. But unfortunately, there's another person. One of them is fictional, one of them is real. One of them's a galactic defender, the other one's a planetary defender. And what really, really bugs me, if I'm walking down the street, someone will yell out, Patrick, Patrick, say it. And so I have to say, let it be so. And that's really not me. But the fundamental question is planetary defence science fiction? So I'm hoping at the end of this short presentation that you will make up your own mind with this. But I had a previous life, and that previous life was working with black holes and exploding stars and gamma ray bursts and counting a lot of photons, and it was great. But I actually transitioned into space debris and planetary defence, which is about protecting the Earth from asteroids and sometimes big objects like space junk. Now, how did I do this transition? How did I go from looking at the edge of the universe to something that is orbiting just above the Earth? I had a conversation, and this conversation changed my life. I actually met for the first time a social scientist. And I knew you were going to say that. And this social scientist confronted me, and we had a talk about it. She was finishing her PhD research, and I said, "What are you doing your thesis in?" And she said, "I'm doing it on the trauma from refugees, how this trauma perpetuates in families to the second generation." What? And I said, "Well, how does that research benefit society?" So this was... This is a true story. The people know me. So she said, "Well, what is your research about?" And I said, "I count photons from 4 billion years away." And so she said, "You do science fiction then, don't you?" So this was a start of something big. But we have to define what planetary defence is. I've made that transition. It took a long time. So planetary defence is really about space rocks. Some of you can see little shooting stars. You probably, if you go outside, you'll see a shooting star. That's a sand grain burning up. But these relics of the early solar system can be up to 10 metres in size. And the frequency of these really depends on how big they are. So what about what planetary defence is not? Planetary defence is not about protecting the Earth from spaceships. That's someone else's job. So let's get clear here. We're trying to paint a realistic picture. Planetary defence is something important, protecting the planet from space rocks. Now, you're probably thinking I'm just making all this up. There wasn't a real event in 2013, just to put a reality check. This event snuck through the Planetary Defenders radar. This event is called the Chelyabinsk event from 2013. It occurred February. It was a space rock about the size of a big truck, about 20 metres in size. It actually came from the direction of the sun, if that's the sun, coming like this. So there was no way it was picked up on radar, on telescopes. It air blasted 20 kilometres above a town called Chelyabinsk, and it caused a lot of damage. It caused 1,500 injuries. Took the power out. Yeah, took the power out. It did too. So that was a reality check for planetary defence. The 1,500 injuries, do you know how they were? How 1,500 people were injured? Glass. Very well. Someone's done their homework. So what happened was there was a bright flash. 1,500 people went running to the windows, looking like this. Windows all exploded from the air blast, from pressure. So this is the unexpected effects of planetary defence. This is the sort of thing we need to understand. So there is another theory, which is probably not true, so we'll dismiss our friend again. But it really gets down to the probability. Like I said, a shooting star is a shooting star, make a wish. But a shooting star is part of the remnants of the space solar system formation. What we are really interested in is the probability of this having a real impact on our everyday lives, and you're probably still not convinced. So what's the probability of being hit directly by a space rock? Very, very small. In fact, the probability of winning lottery is much higher, or lotto is much higher. Now, this is not to say it hasn't happened. Do you want to meet the most unluckiest person in the world? Okay, this is the most unluckiest person in the world. This is, I forget her name, Anne Hodges. This is in 1954. This is the only person in recorded history that's been hit by a space rock, watching TV, lying on a couch. What's the probability of a space rock going through the roof? And then that's really crazy. Now, you're probably thinking then, why would NASA put money into something so improbable? And it takes a lot of lobbying. We don't like to talk about the Anna story very much because NASA's going to go, oh, you know, why are we putting money into this? But NASA does take it seriously, like we just talked about the Chelyabinsk event. But now I want to explain how planetary defence works. There's phase one. It's called awareness. We have to realise there is a problem. How do we realise there's a problem? Well, we just look at the moon. It's full of holes. And all those holes actually came from impacts. But they occurred a long time ago, so don't worry. They still happen now, but they're quite small. The moon plays an important part because the moon is a protector of the Earth. It's a gravitational sink. So when we get a large body travelling near the Earth, occasionally it will be trapped by the moon and impact the moon, which is good. Now, if we don't have awareness, what have we got? There's a movie called Don't Look Up, which I have to admit I haven't seen, but everyone says it's brilliant. I still haven't seen it. But it's about the denial of having this sort of impact. Now, I'm involved in part of this journey, and we have an incident room, we call it. Our incident room is jam-packed full of high technology. It's jam-packed full of really creative people that are working on these problems, but it doesn't actually look like this. It looks more like that. It's just a normal boardroom with a desk and a few chairs and a few bits and pieces. Now, I'm involved in phase two, not in phase one. Now, phase two is interesting because it's all about tracking asteroids over the Earth. We can only do that over Australia because we can't see the other side of the world, obviously. And I'm also involved in what's called the Asteroid Warning Network. There's only 2 people, which I'll show you us in a minute, are involved in this. We're self-nominated people, so we chose to protect you. No one... We chose to protect you, and I'll show you what the area we're trying to protect. This might seem a bit fuzzy because it's all top secret, so you probably can't see the locations very much. So just blink, you know, it'll be gone. So what about? It's actually about trying to monitor optical and radio emissions from fast-moving asteroids. So what about phase 3? You're dying to learn about phase 3. Now, phase 3 people don't mix with phase 2 people. That's the problem. We never know exactly what they're doing, but we kind of know a little bit of what they're doing because we know that they have to do something to the asteroid to either destroy it or move it. So it's either going to be some sort of projectile, or our friend Sasha here, what are they called? The lasers? High power lasers? He's not involved in them. High power lasers, or it could be something like this. Or it could be what NASA really does. And I want you to remember this because this is why my argument is that it's not science fiction. This is real. So NASA calls them kinetic impactors. Is it gone off the screen? Back again. This is called a kinetic impactor. What does that mean? They get a satellite and they just crash it into the asteroid. This is what NASA does. They proved that they can do this. They did it a couple of years ago with a mission called DART. So this is actually real planetary defence. Now, there are some embarrassing moments apart from the Chelyabinsk event. Now, the right-hand side, you will see the Planetary Defence Team of Australia. The person which is on your, I think, left or right? No, on your right is the ex-Deep Space Mission Commander of NASA, and he's quite high up, but he's looking a bit pensive. I like that word, pensive. He's looking, like I really don't want my photo taken. And the reason why, there was a big event that was quite embarrassing for us. This event was called 2024 YR4, which is an asteroid which circles and passes the Earth very close every 4 years. It passed very close in December 2024, very, very close in time. Now, the problem was that there was hardly any data on this asteroid, and the scientists had to rate this on what's called the Torino scale. The Torino scale is a level of threat. And this is really important because this can escalate. And if it's a threat above some certain threshold, it'll be escalated to higher authority. First of all, to get to that stage, it had to go to the International Asteroid Warning Network. Now, I always wanted to show this slide. So there's Ed and myself. Ed is like our spiritual guru. And Ed, God, we love Ed. Anyway, what happened when we went through this process, we had to decide as an organisation, a global organisation, whether this should be escalated to the United Nations. And it was escalated to the United Nations. So then we thought, we need to keep this a secret. And we thought, we can keep this a secret. This is a small group. Unfortunately, it became the worst kept secret in history. It just went ballistic on the radar. So that's why Ed and I are slightly embarrassed. Now, the elephant in the closet is the fact that this happened around Christmas time. So the planetary defenders weren't looking through the radar and optical telescopes. They were too busy partying. They had a holiday. So this one slept through the defences. Now, you might ask, well, this is crazy. Would you really trust these people to protect the planet? Well, luckily, our friend here says this is not science fiction anymore. So I'll leave it there. Thank you very much.